Hi, welcome back. So, as you recall, when we left off, we had a final master luminance image, actually two of them that we saved in TIFF format, and now we need to work on the RGB image. So, you come up here to Process, All Processes, Channel Combination, and you can see here, if I clear this, this is usually the way it comes up. And if you name your files as some name underscore R underscore G underscore B, then when you click on this, it does a good job of identifying the correct RGB colors in the correct channels. Once you have the channel specified, or once you have the channel specified correctly, you click on this and you're going to get an RGB image. Now the first thing I like to do is change this to M51 underscore RGB. Sometimes I've gotten through the whole flow and realized that my entire image was still called image 28, but not the end of the world. You can just change it at the end, but I like to try and change it at the beginning. So then, again, Control A will get you this, or the other thing you can do down here is click this little, radioactive signal, and you get the RGB image. Now, in my next step, I usually do photometric color calibration and then ABE or DBE. The order I do them in depends upon this picture. If the gradients aren't too bad, I'll do photometric color calibration first. But in this case, I think the gradients are pretty bad, so I'm going to do DBE first. So I bring this up. Again, I usually use 35. I like bigger ones. Some people use smaller. I don't know if it really matters, but that's what I use. I then generate, and again, I move things out, make sure that I'm not capturing part of the galaxy. Over here for what it, and if you make this tolerance, let's see, 8.5, 2, 3, 3, oh well, I guess that's not working. I'll put it back to 1. I think it's too close to this star up here and it doesn't like it, so yeah, I just moved it over to there, and now it's good. So I'll put another one here. I don't know why it didn't put samples over here, but I usually just go in and put the samples in manually, like that. Everything else looks, pretty good. Nothing here in the galaxy, and then I click the check mark, and you get this. You can look at the gradient. Now this is kind of blocky up here. There's this little symbol with a 24. It changes this to 24-bit. You get a smoother look at the gradient that it found. And you'll also find that you need to relink these channels, and I think you will agree that that is a much better image. Again, this camera, if you look at it here, it had some issues. I actually had to send this camera in eventually because it was getting this picket fence patterns. There was a problem with the power supply that was doing something funky, and I think it was just starting to do it when I took this image. I also think I need to go back and look, in the first image when I did the weighted batch pre-processing, remember I up-converted these and then did cosmetic correction on the up-converted. I'm thinking it may have been better to do the cosmetic correction when it was still bin 2x2 and then up-converted afterwards. So that may be something, if you look at that you may want to do. Now, to do that, you can't really do image registration in the weighted batch pre-processing. You would have to not do that, and you would have to just do calibration in the weighted batch pre-processing, and then you would have to go back and do the cosmetic correction manually on the the 1x1 binning and then the 2x2 binning, since you'll have different column corrections in the 2x2 versus the 1x1. Then when it's cosmetically corrected, then you can use image registration manually, or star alignment it's called, manually, to then do the registration. So I may go back at some point and look at that, so if maybe I'll even do an addendum or something, but that could be what happened here. But the issue is, it's not going to matter, because this thing is stretched so out of whack from what you would normally do, that when you get this thing into the histogram transformation, these things won't be visible anymore, so I don't think it's really going to matter. So I'm going to move forward with it like it is. And again, once I've done the background extraction, I then, here, oops, make it a little bigger, I'm going to come in here and go to Process, All Process, Photometric Color Calibration, and it's going to bring this up. I click on the image, and then I click Acquire from Image, and it goes and gets the FITS header and figures all this information out. If this doesn't work on your image, you're going to have to do the right ascension, the declination. It needs all of this information. It needs the observation date, or at least as close to the observation date. Obviously with all the images, you just pick one. I mean, if it took you a month to gather the data, it's really not going to matter. You just pick a date that one of the images was gathered. I think that'll be good enough. The focal length of your system, this is my focal length, and the pixel size of your camera. Once you have that, what I generally like to do down here on the background neutralization is I try and find a section of sky that does not have many stars, and create a preview. Sorry about that. Should have muted my phone. So if you look in here, I mean, you don't have to worry about getting some stars, so I'm just going to click again, Alt N as in Nancy. Oops, click here, Alt N, and then, I don't know, somewhere right over here, there's not a lot of stars there, maybe like that. Create a preview, then region of interest, click on From Preview, and use that preview, and that's what it's going to use for background neutralization. And then you just grab this triangle, click and hold, drag it over to the picture, and let go. And then it's going to do its thing. I'm going to pause here real quick and let it finish, and then I'll be back. Okay, so now we've finished the photometric color calibration. These lines just show kind of the curve fits. Not the greatest down here. It looks halfway decent up here, but we'll call that good. And now we have again a nice, it's been calibrated, the color. So the next thing we're going to do is we're going to do the stretch, or the histogram transformation. Now there's two ways that I do this. So at this point I am going to create another version of this, and I'm going to show you the two ways I do this, and I'll explain why I sometimes do it two ways. And I'm kind of working through one way. Again, I'll explain as we go, but the first thing I do is clear the screen transfer function, and then I come up here to Process, All Processes, ArcsinhStretch, and make sure that this is reset. then I'm gonna click on this circle here, the real-time preview. I'm going to click on this square down here, and then here is the core of the galaxy, so I'm just going to draw a little box pretty much just around the galaxy. Then I look at this stretch factor and I pull it to the right just until, yeah, right there where I start to see some decent color in the galaxy. And I am going to apply that to the image. And this is going to tell you, you can see what you're doing now is you're looking at the real-time preview of stretching the stretched one. So again, reapply this, so we zoom in on the galaxy. I go to the black point and pull it down a bit. Now one thing, if you pull the black point down too much, yeah, you start getting these, you'll see these little pixels. Yeah, it's pretty quick, but let me see if I can use, yeah, you'll get these little, it'll let you know you're clipping, basically. When you see stuff like this, sometimes it goes slower and you start getting these little green pixels everywhere, and that's when you know you've gone a little too far. So we'll cape it there, and then we'll boost this up a little bit more to about maybe there. And now we apply that. And well, okay, now all of a sudden that's kind of good enough. And we'll zoom into that. And oh, okay, so we're still clipping, that's not good. So we'll go back to ArcsinhStretch and we'll pull this back down, and we can monitor over here. We're clipping, so that's too far. Yeah, I'm gonna clip, so I messed this up. So see, this is how it works. Sometimes you think, okay, I don't like that. I'm gonna start over. I'm gonna go back, undo the ArcsinhStretch, undo the ArcsinhStretch. So I'm gonna clear it again and start over. So yeah, you think everything always goes smoothly. Everyone goes through this. You're like, oh, I didn't like that. So again, I come to about here. Out maybe a little bit less, and then I'm going to apply that. And then again, I get this here, and I zoom in, and I'm going to lower this black point a bit, but I'm not going to lower it a lot. Maybe a little bit more, because I don't want to clip it. Maybe somewhere right about there. And this looks pretty good. I think if you look in there, you can see a lot of really nice color. So I'm going to apply that. And quit. And minimize this for now. And you can see here, now I usually use this to work on the black point. I'd rather have it too black, and then I can always do it here and reset this. And now I've got a nice, again, I'm not clipping, and if you look at this, there's really nice color, especially in these H2 regions they come out. So I'm going to call that good. So that's the one method I use using ArcsinhStretch. And the reason I don't always use it is it can occasionally do a real number on your stars. I mean, you just get these horrible looking stars, and I haven't fully figured that out yet. So I try it, and if it doesn't work, then I go back to the more traditional way of doing the histogram stretch. And the reason I like ArcsinhStretch, look down here. I mean, look at the color you're getting way down in the core. It does a real good job of getting color into the brighter regions of an image. And so that's why I try and go with it. Sometimes if it messes up the stars, I think, one thing you could do, and I will probably try this the next time I have an image where the stars go south on me, is do the ArcsinhStretch and then do the normal stretch I'm going to show you later, and you know, use a star mask and maybe pixel math to use the stars from the, you know, the one stretch and the galaxy from the ArcsinhStretch. But anyway, that's one way to do it. Now, if I come over here to this, the traditional way is just to zoom in here, actually to create this, zoom into the image here, and then just start pulling, what did I do? Sorry. I didn't want to do that. I want to zoom in here. I want to go to the screen transfer function and start pulling this down to about there. Move this back because I don't want to clip the background. And then I put this in and apply it. And reset this. And now I've got this. I can back off a little bit, maybe about halfway. And so now we've got a stretched image. Okay. As you can see in here, the other thing is we really don't need to do much to this. It's not too bright. This one has the same problem we had with the luminance, that it's a little too bright. Okay, so I believe, yes, I can apply this to this. Usually undo the show mask. I can create a real-time preview. Zoom in, and then I just start pulling down in this area somewhere, I don't know, maybe about there. I apply that, get rid of this, reset this, and then I believe there's the, not the decon mask, I didn't want to do that. This second one, I can apply this and mask, show mask. Yeah, we're just working on that core. And real-time preview. Click on this square over here. Zoom into the galaxy and just start pulling down the, somewhere about there. And click here. Okay, and when we're done, we have something there. Now you'll notice the color here is not quite as good. Now there's a way you can address that, but you can see why I don't necessarily like doing it this way all the time. Now there's a way you can work on this. You can go throughout the flow. You can do the TVGD Noise, which I'll show you. And then once that's done, I use this curves to boost the color on this image. So I'm going to save this for now over here, and I'm going to work on this image. So for this image, the next thing I want to do is work on noise reduction. And to do that, I take again my decon mask, put it here, and then I do mask, invert mask, because I don't want to do the denoise on the galaxy where there's strong signal. And mask, show mask. So I come over here to this TVGD Noise, and this one on a color image, it works on the lightness or the luminance part and also the chrominance. And these are the settings that I use. I think these settings are the same as when I worked on just the luminance when there is no chrominance. And then for the chrominance, these are the settings I usually use, and I find that they work pretty good. You can stop the video and try these yourself and see how they work for you. But basically, when I have this, I just, again, grab this triangle, put it over here, and let it run. I'm going to pause here because TVGD Noise, like the Muir denoise, is going to take 5 minutes or something like that to run. So I'll pause here and then I'll be back. Okay, I'm back, and yeah, you can see here it took about 4 minutes to run that. but I've run TGVD Noise, and so I'll quit out of here, and we're almost down to the home stretch. Again, if I look at this, I can bring this down a little bit more. And then the next thing I usually do is I have this curves here. You can again find all of these. When I have these icons, what I've done is I've gone up to Process, All Process, and Curves Transformation. And you can bring that up and it's kind of in its normal state. What I do is I create a curve I like and then I save that as an icon and I can just bring it up. You save it by an icon, so what I've done here, if you click over here on saturation, that's this curve. I've created a saturation curve, and then what I do is I take this, create a process, and I called that process curves, and then you're done, and now I have a curve. So what I do is I usually apply this to boost the saturation, but on this image, well, let's go back and remove the mask first before you do that. So click here, boost the saturation, and that is entirely too much. Okay, so that happens, and so you say, okay, let's undo that, and let's bring this down, it's somewhere like here, just a little bit, see what happens. Yeah, now that's a little better. If you go back and forward, it's boosted the color just a bit. I think that's acceptable. The next thing I do is I always run a final SCnR to get rid of any greens that are in there. I don't think there's much in this image, but if there's not, it won't hurt. So I usually run that. And if you go here, you can zoom in, and that's a pretty decent looking color image, in my opinion. So the same thing, you'll come up here now, File, Save As, and I'm going to save it as an M51 RGB. Make sure to make it 16-bit and click OK. Now, back to this one where we didn't use ArcsinhStretch, you would do the same thing. You would do the TGVD Noise. I'll skip that, but then you'll come down here to Curves and apply Curves after the TGVD Noise. And I had the mask on that one too. Sorry about that. Mask, remove mask. Then apply the TGVD Noise. And that one actually worked pretty well. You maybe follow that with a little color saturation boost. And yeah, that's okay. What you can do is apply this stretch to this image by you click and hold and then put it over here, and now both these images have the same, and so you can hold down the control key and then with the page down key you can go and you can just see, look at the core and the color you have with the ArcsinhStretch, and then look, it's just not there. And the rest of the galaxy is not bad. I don't think the color here is bad. I just think ArcsinhStretch is better. Once I get a handle on why stars sometimes go south, I'll maybe record an addendum and let you know what's going on there. But for now, the ArcsinhStretch version is much better, and that's the one I'm going to use. Again, I would use a final SCnR on this version if this is and I'd be good to go. But again, not going to use that one. I'm just going to stick with this. And I now have master luminance and master RGB files, and that will conclude in my flow the use of Pixinsight. And again, I don't want to trash on Pixinsight. You can go from here and do a complete, and people do it and they get fantastic images. My flow uses Pixinsight, and the main reason is I find generating masks and doing some of the detail enhancement and sharpening I just find it easier to do in Photoshop, and that could just be that I used Photoshop for 10 years before Pixinsight came along, and it's just easier for me, and I could probably figure out how to do this all in Pixinsight, but you know, when you've got a process that works, I'm not as motivated to spend the time to do to do it in Pixinsight. And also, again, masks generation in Pixinsight I find more difficult. I find it much easier to do it in Photoshop, and that's why I do it. But again, having said that, there are plenty of other tutorials out there that will take you forward from this point and do LRGB combination, and you can kind of see a flow here. You do the LRGB combination, the TGVDenoise, you can use the HDRMT, all these processes you can do to do the image sharpening and generate a final image. So anyway, I hope you found this useful, and for now this completes our use of Pixinsight, and the next video will start in Photoshop with doing the LRGB combination and final image processing. Thanks a lot. I hope you found this enjoyable and useful. If you did, subscribe to my YouTube channel. Thanks a lot.